In this video recording, we will take a look at how we compute double integrals. We compute double integrals by a process of iterated or repeated integration. Let's take a look at the example of this double integral. It is actually already written as an iterated integral. Integration over x, where x ranges from 0 to 1, of a function which is obtained by integrating e to the power x plus y with respect to y, when y ranges from 2x to 4x. The first thing to do here is to determine which integration has to be performed first, and it is the innermost integration. It might be helpful to imagine invisible parentheses around the innermost integral like this. And so our first integration is the integration of the integral inside these red parentheses. Let me compute that integral aside. Integral from 2x to 4x e to the power x plus y dy. Since the integral ends with dy, that indicates that our integration is over the y variable, and x variable is actually fixed. The value of x is fixed, and so we are thinking of x as a parameter for this integration. To compute this integral, we make a substitution. We let x plus y equal to t. And then dt, when I compute the differential of t, I have to keep in mind that x is a constant. And so the differential of x plus y is going to be just dy. Dx is going to be 0 because x is a constant. And we also, since it's a definite integral and we're making a substitution, we also need to change the limits of integration. Y ranges from 2x, so when y is 2x, the t corresponding t value is going to be x plus 2x, which is 3x. And when y is 4x, t value will be x plus 4x, which is 5x. So now I have done all the calculations I need to perform this substitution. We get an integral from 3x to 5x. E to the power x plus y is now t, so e to the power t. And we computed earlier that dy is exactly equal to dt, so I replace dy with dt. And now this is a very simple integral. E to the power t is the antiderivative, e to the power t, one of them. We substitute instead of t the limits of integration, 3x and 5x, and we take the difference. So we get e to the power of 5x minus e to the power 3x. Note that the result is a function of x. Originally we had a function of x and y, e to the power x plus y, right here. We integrated this function over the y variable, and at the end we get a function of x. Well, now this result, this function of x e to the power 5x minus 3x, we need to plug that in back into our iterated integral, where e to the power 5x minus e to the power 3x is the value of the innermost integral, which we already computed. Okay, so I'll continue. the calculation of our original integral. I've done the calculation of the innermost integral, and now I return to the original integral. So we now have integral from 0 to 1 of the function e to the power of 5x minus e to the power 3x. We integrate this function over the x variable, and x ranges from 0 to 1. This is a simple integral to compute. You can quickly guess the antiderivatives for e to the power 5x and e to the power 3x. If you're having difficulties establishing the correct antiderivatives, you can make a substitution: u equals 5x for the first term and u equals to 3x for the second term. And you should obtain the following antiderivatives: 1/5 e to the power 5x for e to the power 5x, and 1/3 e to the power 3x for the second term, e to the power 3x. Now we plug in our limits of integration, which are 0 and 1. Let me continue on the next page. 1/5 e to the power 5x minus 1/3 e to the power 3x, evaluated at the endpoints of the interval of integration, 0 and 1. When we substitute instead of x1, we get 1/5 e to the power 5 minus 1/3 e to the third, minus, when we substitute the value of x equals to 0, e to the power 0 is equal to 1, so we will obtain 1/5 minus 1/3. And so altogether our final answer is 1/5 e to the power 5 minus 1/3 e to the power 3 minus 1/5 plus 1/3. And this completes the calculation of our double integral. So as you can see, it's an iterated integration, repeated integration, where we first integrate over y and then we integrate over x. By the way, the order of integration could be interchanged, but then one has to be careful about the limits of each integration, and we will look at how to do that in another video.